So dear friends, in this particular video, we shall be looking at an investigation of the Faraday's law as well as Lenz's law of electromagnetic induction. Guys, it's a question that is on stations for the physics practical. So guys, the question is that you're provided with the following. We have connecting cables, a 10 centimeter rod, a bar magnet, and an ammeter. We should use a setup we should use the above apparatus to generate a current and hence measure the value of that current. All right guys, so just from the requirements that they've given you, you can already picture it from your knowledge of physics that you know already in theory, knowing that whenever field lines are being cut, right, and EMF is induced. You've been given connecting cables and a bar magnet is involved. No battery has been given, right? So in this case now we need to generate that electric current, and the only way to do it is by cutting magnetic field lines. Okay, let's dive into it. So let's start with the diagram of setup. So that's our diagram of setup. We are going to use that our connecting cables now, and some of them are going to be used to make turns on the rod. Great. So guys, this is it. This is the diagram. So we need to bring for the magnet at one end of it. The magnet normally has one end to be north and the other end to be south. If you reverse it from south to north, guys, here it becomes south, here it becomes north, no problem. Okay, it's still the same thing. All is that you need to cut magnetic field lines such that EMF is going to be generated, which will cause an electric current to flow if this circuit is a closed circuit. Great. Let's go to procedure, guys. We'll say the setup is as shown above, with the wire being wrapped around the rod such that turns are produced. So guys, these are called turns. Okay, turns are being produced. So you can see the bar magnet is being moved at some velocity to and fro the wound rod while observing for any reading I on the microammeter. So for instance, you notice that in this case they gave us a multimeter, right? The multimeter in this case was what they were referring to as our ammeter, but in this case I put a microammeter, right? In this case I've used the micro because the current that is generated that is going to flow in this circuit is going to be very, very small. Okay, the EMF that is going to be generated is going to be very, very small, and the ammeter has to be set to the microammeter range such that it becomes very sensitive to any current change. That's why we have microammeter here and not just ammeter. The current that this our meter is going to detect is going to be of the magnitude micro, very, very small, sometimes micro, sometimes milli. Okay, it's going to be very, very small. All right, so guys, that's it. Now let's go to observation. So we can say that our I in this case, guys, is going to be 5.0 microamperes. According to an experiment that I did, guys, it was I was equal to 5.0 amperes. So guys, in the course of doing this experiment, you're going to move the magnet either to and fro beside this solenoid fast, very, very fast. Okay, very fast. You can either move to and fro or upwards or downwards. What is the goal, friends? Magnetic field lines from this bar magnet should be cut. These our setups we will do are to be able to cut magnetic fields produced by this bar magnet. That's the physics behind it. All right, let's go to our inference, guys. Our inference now is therefore going to be that whenever magnetic field lines are being cut, an EMF is induced which causes a current to flow in the circuit. That's the inference, guys, the physics of your problem. That's it. Then now, guys, let's simply go now to our precautions. We can say that the ammeter is set to the micro scale since the current generated is very small. Great. And second, we can say the velocity of the magnet is increased so that more significant current can be generated. Note that the more the velocity, guys, the more current is going to be generated. Okay, yes. So guys, that's it for this experiment. That's it. If there's something you don't understand, friends, please, I look forward to answering all the comments I see on the comment section, guys. Make sure you ask your question, guys. Have a blessed day and a good luck as you prepare for your exam, guys. I remain humble Mak.